Hi, in this video we will add the last differentiation rule to our toolbox. This, which is called chain rule, deals with the derivative of composition of two differentiable functions. Let me quickly recall that what we have so far. Recall that so far we know how to differentiate constant multiple of a function, sum of two functions, difference of two functions. The product can be differentiated using product rule, and we had the quotient. Yes. Well, this list needs one thing more. How about FOG, composition of two functions? What is the derivative of FOG? Do we have anything good for that? Yes, we have. We will. I will tell you in a minute what is that rule. But you may also approach this rule from other sides by seeing examples that seem very easy to deal with, but with the rules in hand, we cannot find their derivatives. For example, take the function 2x plus 1 to the power 2. Can you differentiate this one? Well, in this case, you would say, well, yeah, why not? I can expand this first, then I get 4x squared plus 4x plus 1. This is a polynomial. I can apply the constant plus sum rule. That will give me the derivative. You're right. For this exponent, for this power, you're right. But how about, let me change my example to something that, how about to the power 10? Yes, you can expand, definitely, but it will take forever. Well, if your expansion is correct, and at the end you're going to have a huge derivative. Well, or maybe instead of that, what about 2x, root of 2x plus 1? This seems nice function. Why don't we have anything to find its derivative? Well, all these cases, any other powers of this also can be differentiated using the chain rule. The first thing to note is that these functions, 2x plus 1 to the power 10, is FOG, where, well, what does this do? First, the inner one is G, takes x to 2x plus 1. Then when it is 2x plus 1, we plug in into fx, which is x to the power 10. Yes, now I know the derivative of this guy. I can differentiate that. I can differentiate that guy. Can I use somehow these derivatives to find derivative of 2x plus 1 to the power 10? Or similarly, this guy, 2x plus 1, root of 2x plus 1, f or g of x, where f is this time root x and g is 2x plus 1. Yeah, so we want to have something in hand to be able to differentiate functions like this, and this is called the chain rule. What is chain rule? Chain rule says the derivative of FOGX. Well, sometimes we like to write it as f of gx. That's the definition of composition. This is equal to this rule. First, find derivative of g prime, the g function. Then multiply it to derivative of f, but don't evaluate it at x evaluated at g of x. This is what we call the chain rule. So derivative of f o g is derivative of g times derivative of f time at gx, evaluated at gx. Well, when you work with like fg names, it makes everything complicated, because at some point you may have fof or gof. Yes, to be able to handle all those cases, I would suggest you to read this chain rule as this: the derivative, not the red one, the derivative of f of gx is equal. You see, f and g, one of them you can take as outer function and the other one as inner function. What I mean by outer and inner is this: this g is inside f, so I call it inner, and f is outside, so I will call it outer. So read the chain rule this way: the derivative of inner function times the derivative of outer function evaluated at gx. At gx. It means that after you finding the derivative, replace all x's by gx. That is the best way to read this chain rule. And somehow it says that why it is chain rule. You bring inner one out first, then the second inner one. If there are more derivatives, you do one by one. Like chain, it will come out one by one and you differentiate. Okay, so let's do some examples. Definitely without these examples we are not doing well. Here I have these examples for you. Okay, let me keep it for now there such that we can use. Okay, I have two functions, f, which is 1 over x, and gx, which is 2x squared minus 4x. Now I want to find fog, the derivative of fog at x. Okay, so this is, we are trying to find derivative of fog at x. This is same thing as, this is same thing as finding derivative of f as outer and g as inner one composed. And the chain rule says what? We have to find derivative of the inner one times the derivative of outer one evaluated at gx, not x. Well, so then I need to find what is g prime of x. G prime is, well, derivative of a polynomial. So you differentiate and then subtract, then constant multiple rule. And then that gives us 2 times 2x to the power 1. This is power rule. And 4 times 1. So we found g prime. G prime is what? 4x minus 4. Let me put it a little bit back there, this one, so that I can use the space there. Yeah. That is g prime. How about f prime? F prime at x is derivative of, that's derivative of 1 over x. Derivative of 1 over x, well, you can use power rule. X is 1 over x is x to the power negative 1 and use the power rule. Or as I mentioned from the beginning, this is a negative 1 over x squared. Okay, we have all the pieces. I need a derivative of the inner one, which is 4x minus 4 times derivative of outer one. Don't put just like that. This is not correct. You have to compose f prime with gx. It means what? It means that we have to do, let me write step by step this thing. We have the derivative, but instead of x, we want to put gx there. Let me just write like that for now. And this means what? This means I have 4x minus 4 times negative 1 over gx squared. Let me raise what this piece was. You can roll it backward and see it again, but I don't want to keep it there for now. So this is what the chain rule says. Derivative of g prime times derivative of f, but plug in gx for x in the derivative of f prime. Well, that will give us negative 4x minus 4 over gx, which is 2x squared minus 4x to the power 2. That is the chain rule applied, and we were able to find that derivative. How about this one? Well, this one we are trying to find derivative of GOF. So I write it this way, and right away you see why I was telling you that use the inner outer thing. Yes, here the inner one is f, the outer one is g. So we have to find the derivative of inner one times derivative of outer one evaluated at inner one. Well, we have all the components up there. F prime is negative 1 over x squared times g prime is, well, let me just write what is f of x. Well, g prime is this function we have here 4, but instead of f of x you have instead of x you have f of x there. So 4 times 1 over x minus 4, and that gives us 4 over x minus 4 over x squared. This guy is multiplied by a minus. That's what we have there. And the last one, GOG, the derivative of GOG. So here, both the inner and outer one are g. This is inner one, this is outer one. So we have to find the derivative of inner one times derivative of outer one, which is again g, but evaluated at inner one. In other words, we will have a 4x minus 4 and 4x minus 4 evaluated at gx. Let me write this one a little bit different way. I will have 4x. Instead of x, you have gx. 4gx minus 4. And that gives us 4x minus 4 times, well, gx is, I found the gx up there. I have it 2x squared, 4 times 2x squared minus 4x minus 4. You see, this is this gx that I put in there. You can multiply, you can simplify and get the final result, but important thing is the chain rule. Derivative of inner one times derivative of outer evaluated at inner one. That's what we have. Okay, I have more examples. Well, then let's go back to the example we started with. Well, how this is going to help us to differentiate 2x plus 1 to the power 10. Well, I see 2x plus 1 to the power 10 as composition of two functions. The inner function here is the one we compute first, 2x plus 1. And the outer function is the one we do at the end, so the power 10. Now we are trying to find h prime of x. It means what? We are trying to find d dx of f at gx. And chain rule says take out one by one from inside to out. So you will do the derivative of inner one times the derivative of outer one times evaluated at the inner one. So I need to find what is g prime of x. G prime of x, 2x plus 1. Derivative of 2x is just 2. Derivative of 1 is 0. So derivative of g prime is, the g prime is 2. How about f prime? This is power rule. So this is x 10, x to the power 10 minus 1, which is 9. What does this give us? So g prime is 2 times f prime, which is 10 x to the power 9. Instead of x, you put gx. And that will give us 20, let me just multiply, 20 gx 2x plus 1 to the power 9. And that's what we have there. How about this other one here? Well, root of 5x squared minus 3x. This is FOG. If we set, you see, first, what we do here is that we find 5x squared minus 3x. So this is 5x squared minus 3x. And then the outer one is root of x. And that's what we have here. So now we're trying to find the derivative of this guy. Then this is going to be the derivative of f at gx. And this gives us what? This tells me that the chain rule tells me that you have to find derivative of g, then multiply the outer one, derivative of outer one evaluated at gx. Okay, let's see. G is this. G prime is, well, this is a difference rule, then constant and power. You will get 10x minus 3. Try to do it step by step yourself and you will see that. How about derivative of f? Remember, you can use the power rule for this, or just remember the rule that we had. We computed once and we put it as 1 over 2 root x. Okay, now g prime is 10x minus 3. F prime is this guy, so it will be 1 over 2 root x. But don't put x there. You plug in gx for all x's. And what this gives me is 10x minus 3 in the numerator over 2 root gx is 5x squared minus 3x. And that's what we have here for this function. Derivative of inner one times derivative of outer evaluated at inner one. Okay, let's do the last example. This example is one of those table evaluating table values thing. So let me bring this a little bit up. Oops. We'll do it. Oh, yeah, this is good here. Yeah. Okay, so what we have two functions which are differentiable functions, but I don't know what are the values of these functions, what are the formulas for these functions. I only know some values of these functions at some point, so 0, 1, 2, and also we know what are the values of their derivatives at those points. Now the question is, what is derivative of f OG at 0? Remember that the derivative of FOG, when you evaluate it at x equal to 0, so this is, I'm writing just to say the same thing. This is same thing as, well, you evaluate, well, let me make it a little bit simpler. Forget that we are going to evaluate at 0. We just find what is the derivative of x, and then we will evaluate it at 0. The chain rule says the derivative of inner one times the derivative of outer one evaluated at inner one. Now, from this, plug in x equal to 0. So it will be g prime at 0. Then multiplied at f prime, evaluated not at 0, at g of 0. Well, we know what is g prime at 0. So this is g prime at 0 is -4 times f prime of, what is g0? This is g, and at 0 is g at 2. Okay, I need to go find one more value, and what is that? That's f prime at 2. So this is f prime at 2. It will give me 2, so it will be -4 times 2, which is -8. That's how we find using the table. Just find the derivatives and then set it equal to, set x equal to 1, and that will give you what you're looking for. Okay, how about this one? Well, I need to first find the derivative of FOG at x, and then set x equal to 0. So this is chain rule. Oh, you see, I just made a mistake that I was trying to say. Don't make that mistake. Derivative of outer one evaluated at the inner one. That's what you multiply to derivative of inner one. So then for this, plug in x equal to 1. So we will get FOG prime at 1 is g prime at 1, f prime at g of 1. And now plug in g prime at 1. Go find g prime at 1 is 0. And then multiply to f prime at g at 1. Well, g is here. Itself at 1 is 2. And, well, this will make everything 0. But let's just find what is f prime at 2. F prime at 2 is just 2. 0 times 2. This will give us just 0. Remember, I had more examples. Yeah, I have more of these. Let me bring them up so that we can see these things and go from there. Okay, nice. You see. Now, we do this other one. How about derivative of GOF at 2? Well, the derivative of GOF is derivative of inner one times derivative of outer one evaluated at x. And when you set x equal to 2, what you will get so let me completely write this one. GOF prime at 2 is going to be f prime at 2, g prime at f of 2. This is f prime at 2 is 2, and f at 2 here, this is 0. And that gives us 2 times g prime at 0. G prime at 0 is negative 4. That gives us the number negative 8. This one was 0. This one was also negative 8. And the last one here, I'm bringing up because I want to have access to our value table. So here I have derivative of f of at x. This is equal to derivative of inner one, which is f prime. Derivative of outer one, this is again f, but evaluate at the inner one. Set x equal to 1, so we have f prime at 1 times f prime at f of 1. Use the table. F prime at 1 is this guy, so it is negative 1 times f prime at, what is f of 1? F of 1 is this guy, so it is 2. No, I made a mistake. F prime at 0 is negative 1. F prime at, yes, sorry. I will go back. I'm happy that I found my mistake here. F prime at 1 is 3. So here I need to put 3. 3 times f prime of f of 1 is 2. So what we need one more. F prime at 2. This is f prime at 2 is 2. So this will give us 3 times 2, which is equal to 6. Again, when you write down the chain rule, then you can use the values of the functions given on the table to evaluate those ones. So this was an introduction to chain rule. We will have a little bit more work on the chain rule, but basically the bulk is here.